All they do. An inverse function swaps the input x. X is also known as the independent variable. The output, which we call y. That's all they do. And Chris mentioned another thing. They're generally speaking the opposite action. That's what they are. Like, what's the inverse of addition? Subtraction. What's the inverse of squaring? Square rooting. We use inverses all the time in algebra, don't we? We use the concept of an inverse action constantly. Constantly. How about in geometry, other than solving basic algebra equations, algebraic equations? Do you ever use an inverse in geometry? It usually happens about this time of year. Usually, at least depending on the teacher, shortly after Christmas break, you start doing a lot of stuff, which is kind of like a bonus question under basic quiz. Okay. I'm going to do a simple 3, 4, 5 right pattern. And I'm going to ask you what the cosine of angle A is. So what? It's a Jameson over hypotenuse. It's 3 over 5. If you don't know trig, hurry up and learn it. If you don't understand the sine, cosine, and tangent, ask your phone. It'll pull up videos, kids. You better know SoCalToa. So she did that with you. And by the way, it doesn't seem kind of like natural because a lot of people don't talk about functions. A is actually the input. It is. It's the input. It's there in the parentheses. It's inside. It's the input. And this is the output. Well, the opposite function would have an input of 3/5. And what would it return? A. It would return the actual measure of angle A. So think back to last year about this time. What was the opposite of cosine? And I swear to God, don't say sine. Don't say tangent.
The CES.
No, that's reciprocal. You guys studied secant. That's good to know. Or no, you probably just know that from the form quizzes. Yeah. You know that from form quizzes. It's not on your form sheet. No, it's not on your form sheet. Not. The function he used for the opposite of cosine was called, and she called it inverse cosine. I call it arc cosine. That's what it is. It's not a true inverse. I think recalc, I might explain that, might not. I probably will this year. It's not a true inverse, but it does the job. And what it is, it swapped the input and the output. The input was 3/5, and the output was now, hey, and you learned that last year. Swear you did. Swear it. Does anybody remember it? Nah. Nobody ever remembers it. They might have to saw it. But you did do it last year. You used them last year. All right, moving forward. How to find the inverse of the function is 3 easy steps. 3 easy steps. So inverses swap what? Input and output. And we call input X, we call output Y. So your first step is simple. Swap X and Y. You might want to write this down, Jordan. I don't know. I don't have a clue. After you swap, what you're going to do is you're going to solve for Y. And when you solve for Y, you're going to end up with an equation that says Y is. And nobody would have a clue that that's an inverse. Glance back to what you did last year. It wasn't cosine anymore, was it? It was inverse cosine as it was pronounced to you last year. Notice that little -1? Now, Y is kind of a dumbed down version of f of x. So when everything's said and done, you replace Y with f raised to the -1st of x. If you understand that f of x and y are the same, just different notation, that makes some sense to you. And we read that, at least I read it, I have no idea how you read it, that is read as the inverse of f of x. 3 steps, kids. It ain't hard. This is a linear inverse. A lot of y'all get to where you can do linear inverses in your head because they're pretty simple. They're really not that hard. I'll talk with y'all about some stuff I didn't talk about in my other classes. That says -3 times x. What's the opposite of multiplication? So I expect that to show up in the inverse. Does that make any sense? It does. I expect it to show up. Let's see what happens. Cameron, what's that y become? No. No. It says swap x and y. What's that y become? X. Don't overthink it. That y is an x. And that x is a y. First steps, that's simple. And congratulations, you did 7th or 8th grade. Right? Resolve for y. God help you on this. Next step. We are. How? Subtract 1. Not that hard. Subtract 1. Last step in the isolation game. Divide by -3. And if you want, you can stop right here. That's a perfectly fine stopping point. If you want it to look like y equals mx plus b, by all means go for it. That'd be -x/3 plus 1/3, I believe. You don't have to go that far unless you want to. So have we isolated y now? And if I just write this down on a piece of paper, how would I know it's an inverse? I wouldn't. Same thing if somebody says cosine of something. I don't know. You've got to use that correct notation. What is the correct notation here?
-1.
Inverse of f of x. That's the last step. All right. They're not hard. They're really not. Let's have y'all do one of these easy ones before we do anything hard. I can get you to understand the easy ones, and maybe you'll understand the hard ones when we get to them. We're not even that hard. Anybody got any questions on it before I keep going, Sam? All right, so somewhere on your white space there, same instructions that you're going to find the inverse of. And I'm going to put that in there, by the way. F of x is, I don't know, let's do 4x plus 3. I wanted to go ahead and get f of x out of the way. I will give you one little hint, because not everybody in here knows. Turbo f of x is a nice way of saying what? Well, why? Not everybody knows that. So anytime you see an f of x, you're supposed to mark it out and put what there? Y. Then you can go ahead and follow your procedure, kids. What I have. I got no issues with that. Got no issues with that. No. Signs are wrong. Solving for one. Why did you change the 3 to 1? Just happens. I'm going to do that too. And ball for each other. Oh. Nothing else. That's right. This is right. This is right. Why did that become negative and that become positive? That's a positive, that's a Good. Good. I did see something a lot of y'all did, and I got no issues with it. I really don't, but I've done a lot of these. I would have actually stopped this function at that. I wouldn't do anything past that, kids. I wouldn't. I said you could if you wanted to, didn't I? I personally would not do anything past that. And it looked like all of y'all had that. There's a handful that didn't, but they're being helped, which is awesome, which means I don't have to. But, did you guys get it? Get it? Get it? There's an easy one. So before we go on doing some more of these, we're going to prove a little theorem here. Proving two functions are inverses. Kids don't like this theorem because of the notation. That is f composed of g of x. You see it? F composed of g of x is x. So it says two functions are inverses if f of g of x is x and g of f of x is x. I don't know why I labeled that f to the negative first. We're just going to call it g of x. And we're going to do it. Okay, we're going to compose f of g of x. When I talk about f of g of x, the first thing that crosses into my mind, and it should be the first thing that crosses into your mind, is what is g of x? Yeah. Do you understand why it's the first thing that should cross your mind? It should. That becomes f of 1/3 x plus 5. Or 5/3. I know some kids have no idea how to do this. That's because you've never tried to figure out how to find f of a degree. Cameron, what does f of 1/3 x plus 5/3 mean to you? Jillian, what does that mean to you? Yeah, what's it mean? You tell me what you're supposed to do with it. Should mean the same thing to everybody.
Plug it in.
Plug it in. Every single x that you see in function f is going to become a what? A 1/3 x plus 5/3. So this will become a 3. The x is encountered, and what does she become?
1/3 x plus 5.
You guys just really don't like function notation, do you? Get used to it. Now you get over that, you do a bunch of it. Now you get over it. Do it. All right, what property you want to kick in? Distributive. I believe if you distribute a 3, you get a 1, won't you?
Yeah.
A single x. What happens when you hit 3 and 5/3 together? Cancels out. And what do you end up with? X. Now this is a theorem that has two parts. You only satisfy the first part. You gotta satisfy both. Wouldn't get it, listen. If you didn't have to satisfy both parts, you'd see the word or. You don't see the word or, you see the word and, which means both pieces have to be happening. So now we go around the other way. We find g composed of f of x. And again, the first thing that should concern you is what that interior piece is. And that interior piece is f of x. And Michael, what is f of x? No, how are you guys screwing this up? Yes. I called on you hoping there wouldn't be a screw up. Shucks. Kyle, what's that mean to you? What does that mean to you? What does g of 3x minus 5 mean you do? Plug in. Every single x that you see in function g becomes what, Mother? Every single x in function g becomes what? If it was g of 2, what would every x be? It's not. It's 3x minus 5. So every x becomes x minus 5. Right now the third, counter the x, she's a 3x minus 5. And plus the 5/3. Doesn't have an x. I got 3 fingers here. What's the third of 3? 1. Now the third and negative 5. Negative 5/3. plus 5/3. X. Well, is the first part happy and the second part happy? What do we know? They're inverses. What do we know? Mill theorem. I don't know if it's in your homework or not. I cannot recall.
By homework, you mean the twin?
No, I mean that big old packet with 98 questions. Key concept, one-to-one function. All right. Do any of you guys have more than one boyfriend or girlfriend?
Probably gonna be a no.
Do any of you boys have a girlfriend?
It's also gonna be
All right. So let's say somebody had more than one boyfriend or girlfriend. Are they in a one-to-one relationship? No, that should be pretty apparent. And even if you only had one boyfriend or girlfriend, what if they had more than one boyfriend or girlfriend? Would it be one-to-one?
no.
No. A one-to-one function is a really simple rule. Every input x has how much output? Every input x has only one output y, and the vice versa has to be true. What is every output allowed to have? It's only allowed to have one input. So every output y has only one input. That's what a one-to-one function is. There's something special about one-to-one functions. Only 1-to-1 functions, have what we're talking about today, have inverses. If you're not one-to-one, you can't invert it. Because if a function had two outputs and you inverted it, how would you know which output creates the required input? You wouldn't. That's why it is the way it is. You have to be one-to-one. With Miss Garner and with me at the beginning of the year, a little side note here, before I go back to this page, you talked about the vertical line test. There's a little side note here. Remember what the vertical line test did? If there's a thing, yeah. A graph represents a function in general if a vertical line intersects exactly once. That was a vertical line test. Miss Garner taught it to you. I taught it to you. I can think of at least 2 tests that I gave you at the beginning of the year where you had to demonstrate mastery of it. They were multiple select. You may or may not remember that. I do. But you had to demonstrate mastery of understanding the vertical line test. I remember Micah said if only every test could just be looking at graphs and tables. Does Micah remember saying that? So do I. So here's an extension of that. It's called the horizontal line test. So vertical line test tells you if you're a function. What do you think a horizontal line test does? What did we just talk about? One-to-one. It says a function is one-to-one if and only if its graph is intersected by a horizontal line at only, and I left off the word one there, 1 point. Your hands ain't cramping, you ain't writing fast enough, kids. Should ask your parents about Miss Oliver, if they ever had her. You guys realize how good you have it. All right, so we're supposed to turn on the next page. Determine if the following functions have inverses. All right. What kind of functions have inverses?
One-to-one.
One-to-one. That's kind of the deal. Only 1-to-1 have inverses. How do you know if you're 1-to-1? Horizontal line test. All right, deal is you can only hit it how many times? Once. That's how hard this test is. Inverse or no? No. I'm gonna write down HLT because I don't want to write horizontal line test. It fails a horizontal line test. Does she have an inverse? No, there's no inverse. I didn't mention the vertical line test in the beginning. That's a focal. The circle of function.
No.
That's not even a function.
That's just.
Not even a function. It's not functional. So if it's not a function, will it have an inverse?
No.
The odds you remember that, oh, God, something not. Right? But maybe you'll remember one of the two. Does it pass the horizontal line test?
No.
No, of course not. So it also fails the HLT. Which means no inverse. I have no idea what the opposite of circle is. I have no idea. All right. I can move up a dimension, but I can't move back a dimension on a circle. All right, this is, what is that function? G of x is what? How do you read that? Cubic or cubed root of x, one of the two. Some people can't read it. Some people would be like 3, some radical symbol x. Don't be that people. Don't be those people. Well, that thing passed it. Horizontal line test. Of course it will. It's right through the middle. Yeah, well. So there's not some numbers up here, but this is the cubic root of x, right? Tell me what the cubic root of a is. So there'd be a 0.28 on the graph. Sorry, 8.2. Tell me what the cubic root of 125 is. So there'd be some point 125.5. Is the graph growing? It didn't flatline, did it? No, it did not flatline. It just grows slower and slower and slower and slower. Eventually, it actually appears to flatline, but it never actually flatlines. So this is definitely a pass. Does it have an inverse? Does have an inverse. And right or wrong, I feel that you should know what it is. What is the inverse of the cubic root of x? X cubed, because inverses are opposites. And since this is g of x, we'd say g to the negative first. So not only did we determine if it had an inverse, we found it. Those are easy, by the way, but that's really easy. Any questions so far? Nope. Well, there's the same function that you had earlier. You just look to your left in your notes, you'll see where we had negative x squared plus 5, and it didn't have an inverse. Do you see it? Why didn't it have an inverse?
Because it was correct.
It went both ways. Okay? There's something going on here. What's it say about the x values?
Greater than 0.
So what that does is says you can no longer feed me -1, right? Right. If I can't feed you -1, if I can't input a -1, would I have an output there? No. It only causes half the graph to be drawn. I hope you understand that. What's there is called a domain restriction. And domain restrictions make things that are not invertible, invertible. That's what they're used for. It makes something that you couldn't find an inverse of invertible. That's why I call inverse sign arc sign, because there's a domain restriction there. It's not a true inverse. So we're going to write an inverse for this one. I'm going to. Not a true inverse. But once you restrict domain, you end up with things that you can take inverses of, because does that graph pass the horizontal line test? It does. Passes the HLT, which means it has an inverse. And I'm going to do this in my head real quick, so I hope I get it right. I feel like that's right. Why a square root? Opposite of square. But, you know, the reason I did that was not to just wow you with my ability. For all I know, I'm tired, it's wrong. I'm pretty confident. I don't like to do things in my head like that. But I wanted to focus on the square root. Does that make sense? That's the big thing. Focus on that square root. All right. Speaking of square root, there's a square root. And you have yet to ever in your life grasp square root in this calculator in front of you. So we're going to do what you always do when you don't know what something looks like and you have technology. You make tables. You don't know how to graph something. You go back to 6th grade. They had you plug in numbers, right, and plot points. About the year I learned it. So let's make a little table. We have our input x and our output is whatever the square root of that thing is. Let's see, I think this was done yesterday. I don't know. Smallest number that you can take the square root of. Zero. Second smallest number that you can take the square root of. One. The reason I say the u part is some people would be like, 2. You can't take the square root of 2, can you? No, you can't. Your calculator can't. You can't. Next smallest thing that you can take the square root of. 4. So there's your x values. What are your y values?
0, 1.
2. By the way, notice that the square root function we talk about only returns positive numbers. That's by definition. It's only when you solve for x that you include what? Plus or minus. Somebody asks you what the square root of 16 is, you're not supposed to say plus or minus 4. Say 4. You're supposed to say 4. The square root function only returns positivity. But if somebody says x squared is 16, what are you supposed to say? Plus or minus, because there's 2 answers there. We got 0, 0, we got 1, 1, and then we got 4, 2. And that's what that thing looks like. And you are expected from here on out to know what the square root function looks like. I hate it for you. So we gave it a nickname. Now, the nickname probably originates from the 40s or so. That's the nickname. What is that?
That's your arm.
That's the nickname. The arm. Parker said fist. Because I have my fist goes. We call it a fist. No, we call it an arm. I don't know where you got that. I've done this for years. Nobody's ever said fist. Ever. So that was new. Yeah, often also is actually there's something new that's funny. It rarely ever happens. All right. So will that pass the horizontal line test?
Yeah.
Definitely. I'm not even gonna draw it. Pass that horizontal line test, which means it has an inverse. And you ought to know it. X squared. Was that Mackie? Good job, Mackie. I always knew you were smart. If I could get you to work, you have straight A's. All right. So now you've got the last couple of pages, which is actually going to write slightly more complex inverses. 3 things left, right?
Yeah.
All right, let's write down those rules for writing inverses. What's the first one? Swap x and y. This is for you, not me. Swap x and y. After you swap x and y. Nope. Solve for y. After you do that. Replace y with the correct notation. The inverse of f of x. If it's not y, like if it's g or whatever, same thing. So I'm going to kind of do most of these with you. You guys can play along and tell me what to do. But that f of x again, what's that? Just another way of saying? It's a y. So I don't expect this to be your first line, but I'm going to type it out. Y is x minus 2 raised to the 1/5 power plus 8. Usually at this point in time, a struggling kid is all concerned about that 5. They're all worried about that 5th power. Don't be like that kid. If my engine and my truck is knocking, to figure out what's wrong, isn't there a lot of stuff in the way? Worry about that. The kid who doesn't struggle doesn't worry about the major problem until they get to it. So what are the little problems? Oh, besides the fact that I didn't swap, right? Which I forgot to do. The little problem that's easy to fix, that anybody can fix, that you can pay the guy making minimum wage, is to do what? Subtract 8. There we go. That's the little problem. That's the one anybody can do. But a lot of times kids just see something they don't know how to handle and they just quit. Which is doable, which is understandable, but if we just start doing the work, you'd be amazed what's up here. You may not even realize what's up here. I taught you how to counteract fifth power probably last Wednesday.
It's real one-fifth hour.
One fifth power, fifth root, whatever. Okay. And if you forgot, the opposite of any power is the reciprocal. What it is, the opposite of any power is always reciprocal. If for some odd reason, and the ACT loves to do stupid crap like this, it's kind of what I use when sometimes I say smiley faces. They'll come up with these new little symbols and define operations. True. I don't know why they do that, but what's the reciprocal of a smiley face? Don't say frowny. 1 over, right?
1 over.
1 over the smiley face. Everybody should know how to reciprocate. So I think Ashley told me that the opposite of the fifth was the 1/5. That works because of the outcome on the right-hand side, because we know that a fifth of 5 is what? 1, which is an understood concept, right? That's why it works. It just frees up y minus 2 over here. 2 steps and you're done.
Had to.
By the way, there's kids out here whose next line would be like x minus 6. I know you exist. Don't break the wrapper. There's a joke in there somewhere too.
Sometimes you can't help it.
Sometimes you can't help it, right? Whatever. Anybody lost anything so far on this?
Brain still.
That's from what you did prior to my class.
It doesn't matter.
What do you replace y with?
That's the name of one of those.
All right, so we're good on that. The state of Tennessee likes to test you on multiple things at once. You got like a 55 question test over 300 plus standards, which means that some questions have multiple standards on them. Any other way you think you might see this represented as an answer choice? Square root. Yeah. It's a good chance on this. I'm not saying it will happen, but if I was a test writer, I would make a final answer look like this. Because what I'm doing is I'm testing the ability to understand a whole lot of different things at once. I'm understanding that you understand the conversion between exponential notation and radical notation. In addition to knowing all the steps of isolation, I'm able to hit more than one standard. So I could see that being a possible answer. No, that makes sense to you, Ron. But I can see that. Let's see here. The original power was x minus 2 to the 5th, and our inverse had a 5th root, right? Making sense there? Sometimes kids kind of establish, there are some patterns in some of these that you can catch on to. I won't teach patterns, but they do exist to some degree. They don't exist in your final example. And we're left to B. So that guy is a Y. And Lydia, after you made that a Y, what would your next line look like? What do you do with X and Y? So what would your next line look like? minus 2. Sounds good to me. I got 0 issues with that. And you just play that good old isolation game. That's all you do. Great, what do you want to do? That's right. Four. Stafford, you're up next.
Where, X plus 4.
Not yet. Divide by 2. Easy stuff first, kids. Now, remember how I told you with some of these fractions, I wouldn't worry about breaking it apart? I would not break that apart because of what you're going to have to do after this. Hopefully you know what you're supposed to do after this. And Reese, what's the next step? What's the reciprocal of a half? 2. Opposite power is always what? Opposite power is always the reciprocal. That's why I asked you what the reciprocal was. If you don't know what to do, when you see a power, reciprocate it. Reciprocate it. All right?
What happens to the minus 4 after the last one out?
That guy?
Yeah.
That guy? Well, not everybody sees that. You know, there's a lot of kids that still write underneath every line like plus 4, minus 4.
Oh, yeah, I did.
They got moved. They got moved. Honestly, I know why teachers teach that way, but man, a lot of kids just stick with it. What's half of 2? 1. All right. So you're looking at this thing, which is x plus 4, get a bigger set of parentheses, over a 2 all squared, and it's now equal to y minus 2. If you were in the class after this, which is pre-calc, maybe even do one or by any class after that, you would be expected to figure out what that is. You'd be expected to write it twice before. Not hard. It's x squared plus 4x plus 16, sorry, x squared plus 8x plus 16 over 4. Maybe you see that really well. You're not in that class, are you? In this class, that's good enough. What do you add to both sides? 2. And that would be your isolation, wouldn't it? So what do you replace one? Inverse of f of x. Not hard, kids. Not hard. And you're only algebra 2, so it's not like you have to do a whole lot of tedious work with that. Or maybe that was tedious work to you, I don't know. And the last one is something I started preparing you for way back in August. Believe it or not, you can go back and look at your notes. You'd probably see some stuff where we did some of this. Write the inverse of a rational equation. Everybody knows first step. Austin, what's f of x going to become? What is f of x going to become? Which is going to become x, right? F of x will become x, won't it? Because f of x is y. Swap them around. Cameron, every x you see becomes a y. That's easy. Everybody can do the first step. Jillian, you got an idea? That's one way of setting it.
So it would be 4y plus 5.
Not plus 5,
I mean,
minus 5.
minus 5.
What you want to do here is you want to get rid of fractions, right?
Yeah.
And to get rid of fractions, you multiply by the LCD, which just happens to be 4y minus 5. If you do it to the right, you get to the left because of this concept of equality that exists on that equation. I hope you guys finally understand what that means. What happens on the right-hand side? cancellation, clear as fractions. And you get this. Whoops. Should be 4yx minus 5x. I think that the bell rang, but we'll just work over just a little bit. Y plus 3. I know you've done problems like this in here. The goal here is not to solve for x. What's the goal to solve for? Y. So you think back to when you still love learning in 7th and 8th grade, you had x's and numbers. You got everything with an x on one side, everything with a number on the other, right? Well, here you're solving for y. So everything with a y on one side and everything else on the other. So does 4yx have y?
Yeah.
Go ahead and leave it where it's at. What else has y? Y. What happens when you jump equality? Minus y. Everything else? Other side. 5x plus 3. First amount of math. Pull it, pull it. Pull a y from 4yx minus y. What remains?
4y minus 1.
You mean 4x minus 1?
Yeah.
Whatever you say, because that's the right. What's the understood symbol between that y and that set of parentheses? And what is the inverse or opposite of multiplication? Division. So you divide both sides by 4x minus 1. And I believe you're done. Aren't you?
I'd say so.
As long as you tell somebody it's actual what? You have to tell them that. You have to tell them that, because how would they know? They wouldn't know. That's inverses, kids.
That's not fair hard.
It's not, but we'll see what happens by Wednesday.
Not waiting now. We can, I'll remember that.
That's why you start studying.
I do study every day.
Study what?
I study my TikTok. You gotta watch it long before
You guys have lots of stuff you can be doing. What's up? I don't even see it.